So let's see how you can go about creating REST endpoints in MVIS. We'll log into the administrative console here, and if we click on the account section, let's just take a look at the account that we're going to build the APIs on top of. It's running on localhost and the XDemo account for Universe, and we're going to build a REST API on top of this account. We'll go over to the REST server tab, and we'll create a new data resource endpoint. And data resources are endpoints that are based on files. So if we go to the members file out of the XDemo account, we can create, well, first we'll see the dictionary items that are available to us. These will be turned into JSON when the endpoint is invoked. Let's just pick all D type items and say OK to that. And we'll click View Swagger to give it a test run. You go to the members and you can see there's the CRUD based endpoints, get, put, post, delete. Let's just get all of the members in the interest of time. We can try it out, and we'll leave everything blank, which again will just select the entire file. No sorting, no filtering. It'll take a little bit of time because the file is quite large. It takes a little while for the browser to parse it, but once it returns, we'll see the JSON encoded list of member records. And here they are. So in a similar fashion, if we wanted to create a REST endpoint against a subroutine, we can click on Add Subroutine. And I think we'll build one on very simple subroutine, just a hello world subroutine that takes an input name and outputs a greeting. So we'll build based on that one. We'll say subroutine name, hello BP. And we'll add some parameters, the input parameter and the output parameter. So the input parameter is just the name, and the output parameter will be the greeting, and they're both just simple string types. We save this away, and that's all we need to do to generate a subroutine-based endpoint. We can try it out here with the Swagger button in our Swagger test harness. And you can see here, if we click try it out, it suggests the payload that we'll need to supply. We'll give it a name and hit execute and get a greeting in response. Hello MVU. So you can see it's relatively simple to create both file-based endpoints and subroutine-based endpoints in MVIS. Let's take a look at a few new features that we're rolling out for the next version of MVIS. One of the most important ones are what we're calling vanity URLs or flexible URLs. Basically, it allows you to define URLs of your choosing, whether they're calling data resources or calling subroutines. You can name them whatever you want. So the URL itself can be of any format that you choose. Further, as part of that, we're also opening up the entire HTTP request and response to subroutine parameters. So let's take a look at what that might look like and then show a brief example. So in this stage, we've got a new file. It's called endpoints.yaml, and MVIS is able to get its endpoints from this file. This opens up quite a lot of flexibility around what your URLs can look like and how they can behave. So let's take a quick example to make that a little more concrete. So if we look at this is one endpoint that we've defined for MVIS, and it's got a path named API version 2 subscription members, and then it takes a dynamic variable called ID to be supplied at the URL. So what happens when this endpoint is called? Well, the first thing to note is it's a database operation. Database operations can be reads or writes, They can be calls or deletes. Calls would be subroutine calls. So in this case, our database operation is in fact a subroutine call, and it's going to call the subroutine named getMember. It's going to be run in the account xdemo, and it's going to take some parameters that are bound to the HTTP request and response. So the first parameter is going to be the ID parameter, and it will be bound to the path parameter of the URL. So that was the ID in the squiggly brackets that we saw when we identified the path for this particular endpoint. It's an input parameter, and actually we should probably take a quick look at what getMember looks like. Here's the subroutine that's going to be invoked. It will take an ID that happens to be bound to the path parameter ID variable. It's also going to take in an HTTP header, a request header called content type, and it's going to respond with a response. This last parameter is going to be bound to the response body in its entirety. So we can get a more clear view of that in just a second, but let's just look at what the subroutine does. So it's going to issue a query against the members file, and however, depending on whether the content type is set to application XML or anything else, it will change how it the results that it returns. So if it's an XML request, it'll format the query via XML. If it's anything else, it'll format the query according to JSON and send the response back in the capturing clause. So let's go back to the endpoints.yaml file and look at the rest of the definition of this endpoint. So we already know that the ID parameter is bound to a part of the path, and we know that the second parameter in position 2 is bound to a header variable called content type. And lastly, we know now that the response is bound to the HTTP response body in its entirety. So whatever is generated by the subroutine in the subroutine parameter will be sent back as the response body. So let's see how that works here. Refresh our endpoints, and let's use Postman to send our request. So we're going to make a GET request to that URL we were looking at, and this header type here, this content type, is going to drive whether the response is in JSON format or XML format. So let's use JSON first. We'll go ahead and hit send. And we do see that the response came back in JSON format. If we change this to XML instead, application XML, and try again, if we scroll up, we see the response is indeed in XML format this time. So this is that demonstrated, I think, how you can have complete freedom over the shape of your URLs. You can also define how subroutine parameters are bound to different parts of the HTTP request or response. Just to see a few of those, let's hover over the binding tab and see what our choices are. We can bind to the request header, the entire collection of request headers, in which case they're going to be attribute mark delimited and individually value mark delimited on the basic side. Path param, we already looked at. We can bind a subroutine parameter to the path in its entirety. We can bind to a particular query string in the URL or to the query string in its entirety. We can also, if it's a JSON formatted request payload, we can bind to particular parts of the JSON document via the JSON path syntax. Similarly, if it's an XML document, we can bind to parts of the the request body using XPath syntax. And then on the way out, we can bind to response headers or individual response header. We can use templates to transform dynamic arrays into any type of format that we'd like. and we can bind to the status itself, the HTTP response status. So those are the types of things you can do. We'll take a look at one more example. It's a bit interesting. We created a quick example of allowing us to create a GraphQL type of an API through MVIS. So here we've got an endpoint that's listening to on the GraphQL path, and it's going to call a subroutine called GraphQL. That subroutine is going to take as input the entire request body as a string, and when it finishes its work, it'll send the response out and bind it to the response body of the HTTP response. So it's two simple parameters. If we take a look at what GraphQL, the subroutine, looks like, you can see that indeed it does take the GraphQL query as input and returns the result. We're going to defer to a Python library called Graphene that's going to do the heavy lifting for us to parse the query and return the result for us, but we will still use BASIC to do the actual physical query against the database. So if we look at what this GraphQL members Python program is, we can look at it here, and we see that it sets itself up using Graphene, but the important thing for us is that when it's doing its work and resolving a query to the members file, it's going to invoke get member details subroutine, passing in the ID that was sent in the initial request. And on the response side, it will return a member that is, the subroutine itself will just simply, we can take a look at get member details actually is what we should do. If we look at get member details, it's about as simple as you can imagine. It just reads a record from the members file and returns the result as a raw database record in this simple example. But what our Python code does is it takes the result of that and converts it to a Python list here, and then simply returns it as a well-formatted member Python-based object, and basically Graphene, our GraphQL library, takes it from there and does the rest of the conversion for us. So let's see what that looks like in action with GraphQL. GraphQL lets us send, let's go to the GraphQL query actually. So GraphQL queries are formatted in this type of a manner where you specify that you're making a query and you specify what parameters you're going to act as inputs to the query. And then finally, and when the query returns, you specify what fields you're interested in being returned to you. So GraphQL gives you a lot of flexibility around querying. It avoids the problems of asking for too much information or not enough information in a single request. You can tailor your request exactly as you as the client need. So let's just try to run it here real quick with all of our fields requested first. And we get back this data in the response. Here's the results of the query, and there's no errors. Now, where we get to the interesting part of GraphQL, let's say that we're no longer interested in the address or city or state, just the ID, the last name, and the zip. We'll issue that again. And you can see that the response back was a limited subset of the fields because we limited our query to those particular fields. So that's one of the advantages of GraphQL. We're not going to go into a lot of detail on it. This was more just a demonstration of with the flexible URLs and the fact that you can bind any parts of the HTTP request or response to basic subroutine parameters gives you a lot of flexibility on what your endpoints can look like. And so that's an upcoming feature in the next version of MVIS.